Right, good morning. Here we go. We're going to look at some volumes questions this morning. And the key question that brought up this topic was this one that caused problems in an exam for my students recently. And that is the question we're going to be looking at the skills we need to do to be able to solve this. First of all, the first thing you need is you need to be able to know all these formulae for pyramid, for cone, for spheres. Okay, for prisms, you need to know the volumes of prisms. You need to know what a frustrum is, and you need to know cylinder, knowing that the area times the length will give you the volume. The surface area is equal to the two circles either end times by plus the area of the rectangle which goes around the outside, which is found by getting the circumference times by the length. That. I'm not going to go into detail about the formulas. Those are just formulas. They're on the sheet here. You can look them up and you can learn them. What we're going to look at is we're going to look at the actual problem solving involved in these questions. And so what we'll do is we'll start off with a nice straightforward question of the type where we've got to try and find something that's unknown, where we got two things which are compared. So let's look at this question. It's Jane makes cheese. The cheese is in the shape of a cuboid. In case you can't see this length here is 2. That length there is 10 centimeters. That length there is 15 centimeters. And she now wants to make a use that to make cheese of 5 by 5 by x. Okay, and wants it to have the same volume as the previous one, the 2 by 10 by 15. So I'm just going to give you a couple of minutes to get your teeth into that question, see how you'd get on, and then we'll move on to something a little bit more taxing. Right, here we go. So what we're going to do is obviously we need to work out the volume for this one. So the volume for this one is 2 times 10 times 15. And we know the volume for this one, second one, so if I call that volume 1, and volume 2 for the new one is 5 times 5x. Now, to make the calculations easier, actually it's not worth timesing these out. If you're on a non-calculator paper, it's much easier if you actually do it like this. So we want to divide by this bit here, the 5 times 5. Let's just divide by the 5 times 5. So you get 2 times 10 times 15 over 5 times 5 will equal x. Okay, and then we can see that 5, because there's times everywhere in between, here, here, and here, and there's a divide, there's no adds or minuses, okay, there's no equals in between, we can actually just cancel down. When you've only got times and divides involved, you can just cancel down. There's no worry about the order you do things. So we can just cancel down. We cancel that 5 out with some of the 5 there, which leaves you 3, because 3 times 5 is 15. Cancel some of that 5 to leave 1, with that 10 to leave 2. So on the top we just have 2 times 2 times 3, 4 times 3, which is 12. That is how you can do that with a calculator. So now we'll just step things up a little bit more. Here's something a bit trickier. So you've got a cylinder. In case you don't remember the volume of a cylinder, just remind you it's pi r squared times by the height. Okay, the base area, that's your pi r squared, and then you times by the height to get your volume. That's how you do cylinders. I'm just going to give you again another couple of minutes to have a go at this question, something a little bit more tricky. Sorry, I forgot to give you the volume of the sphere that you needed here. But you could have looked that up if you've got the notebook open. Back here, there's this volume of the sphere, 4/3 pi r cubed. Let's go back to the question. And let's see what we've got to do. Again, you're not going to look to try and times anything out. You want to try and cancel things out in all these questions. Don't try to multiply out too much. Multiply out as a minimum. You want to be able to cancel out your pi's in these questions. Okay, so you don't have any nasty answers. So let's just do the volume of the cylinder. So we'll do volume of the cylinder, VC for volume of the cylinder. That's equal to pi r squared, and r is equal to 2x. 2x. Now, a common mistake is not to square all of this. So someone might get 2x squared times by the height, 9x. When you multiply that all together, 2x squared, well, 2 squared is 4. I'm going to leave this just as 4 times 9 for now. Might save me some time later on. It might not. I might end up timesing by it. We'll see. And I've got x squared times x is x cubed. And I've got the pi. Notice I've changed the order that I've written these things in. So I've put the number, the letters, the pi. Generally, most mathematicians may put the pi first. It doesn't really matter. So if I had 4 times 9 times pi times x cubed, that might be considered a little bit neater. way to write it, but it doesn't really matter. That's the volume of the cylinder. Now we want the volume of the sphere. Now the volume of the sphere is going to have radius r, so this is going to be 4/3 pi cubed. That's going to equal the volume of the cylinder. So we have 4/3 pi r cubed. This is going to equal times x pi. And you can see straight away why I didn't times the 4 and the 9 out, because I can cancel out that 4, that 4. They're both on the top of the fraction. I can cancel out that pi with that pi because they're both on the top of the fraction. Now we've got this 3 here on the bottom of the fraction, so I can't cancel it out with the 9, alright, because it's on the bottom and this is on the top. If you can imagine this is a fraction over 1, then I can't cancel those out unless they're both on the top or both on the bottom. So what I'm going to do is I'm going to times that by 3, so I'll get r cubed will equal 3 times what's left. We've got 9 and the x cubed. Now, r cubed is equal to 3 times 9. Now I've write it as 27, or you might even realize it's just 3 cubed. I'm going to write 27 because most people would write 27x cubed. And then you want to cube root both sides. So cube root the r cubed to get r, and I want to cube root to the 27x cubed. Well, the cube root of x cubed is just x. The cube root of 27 is just 3. The answer is r equals 3x. So what we've done in this question, look at it, look how we've gone through this, and we haven't really multiplied anything out. We looked for things to cancel to make our answer simpler at the end. And that's what we're going to be doing in most of these questions going forward. Look at some more questions here. We're going to have a look at this one. It's a little bit tricky. Let me just zoom in. So I'm going to give you a little bit more time to do this question. Okay, and I'm going to give you about 3 minutes to get your teeth into this one. going to give an extra minute on this question, and let's get lots of comments in the chat saying this is really easy, got it already. Right, let's have a look at the question. If you haven't finished, don't worry. See if you're getting on the right lines. Answer. I'm just going to create some space for me to work in. And the tricky thing about this question is so much information going on. Where do you start? Well, got a connection between the surface areas, so therefore surface area, total surface area of the cylinder is twice the total surface area of the sphere. That's the place probably to start. So we'll have the sphere here, and we've got the surface area equal 4 pi r squared. So it's 4 times pi times squared. Cylinder here, and we know that the surface area of this will equal pi r squared h. So r is 3, so we got pi times squared h plus another 2 lots of these ends, got an end here and an end here for the total surface area. So 2 times pi times r squared again. So, and we know that the total surface area of the cylinder here is twice that of the sphere. So if we do 2 times the sphere, which is 2 times 4 times 6 squared times pi, that will equal 3 squared times squared times pi. Now I'm just going to try and simplify things down a little bit. We can cancel out the pi's straight off. Pi everywhere. And actually there's a 3 squared everywhere. Now how can I see that? Well, 6 squared is just 2 times 3 squared. So if I cancel out that 3 squared, that 3 squared and that 3 squared, and that will leave me just 2 squared here. So I've still got the 2 times by the 4 times by the 2. That's all I've got on that side. Equals h plus left over here just the 2. So 2 times 4 times 2, so that's 4 times 4, 16 equals h plus 2. So I know that h is equal to 14. Calculate the ratio of the volume of the sphere to the volume of the cylinder. Well, the volume of the sphere, so let's just keep working down. So the volume of the sphere is equal to 4/3 pi r cubed, and that's 6. And the volume of the cylinder is going to be pi times r squared, that's 3 squared, times by the height, which is 14. And we want to find the ratio of the volume of the sphere to the volume of the cylinder. So let's just simplify this down a bit. Now what we can do for the ratio, okay, we've got 4/3 pi times by 6 cubed 2 pi. Straight off again we can cancel out the pi. right? We can cancel out the pi's. We can do some other cancelling down. We can see that we've got a 6 cubed here, and we've got a 3 squared here, and there's a 3 here. Well, let's just take, actually, what I'm going to do, make it simple. I'm going to take that 3 to the other side and make it a cube here. And we know that 6 cubed is the same as 2 times 3 all cubed. So we can cancel out that 3 cubed with that 3 cubed. So we're just left with 4 times 2 cubed, 2. Looking on that, so I'm just bringing it down. So I have now got, just cancel out one of these 2's, because that's 2 times 7. 7 there, cancel out one of the 2's, that gives me 4 times 4. That gives me 16 to 7, my ratio. And I can't simplify that any more. So notice how I didn't do any multiplying out. I used the factors to help me cancel things down by splitting things up into factors. And see the importance of being able to write things as factors in making this question easily. You could multiply this all out, and then try cancelling down by 2, by 3, or what have you, if you find splitting up into prime factors like this really tricky. There's no right or wrong to that. This is just a way I would do it to make it quicker and easier without a calculator. So never working with any big numbers at all. Right, let's just look at the question I was going to go through, guys. I let you have a go at the big exam question, which is trickier than all of them. Right, here's another question. I'm going to get you to again just work in terms of pi. This is nice and straightforward to finish off with. You can work out our answer in terms of pi. So again, you're not going to be using calculators to do this. It should be easier. I'll just give you, just using the formulas that we've used already, give you, let me see, 3 minutes, plenty of time to have really good go at this. Okay, right, let's look at this question. Should have been a little bit easier, but how many of you noticed? Now, previously, we've talked about surface area of a cylinder is equal to the height times circumference, so it's going to be pi r squared h plus 2 lots of the ends, which is, it's not pi r squared h, so height times circumference h for the curved surface area, and then for the ends we've got 2 pi r squared. Now what we notice here is we've got a hemisphere at one end covering up one of the ends, so the surface area of the cylinder we're only going to use that plus what we've been given here from the hemisphere. Therefore the surface area of our shape 2 pi RH but the radius of the cylinder is equal to the radius of the hemisphere. So what we're going to do is we're going to have to realize that the surface area of the hemisphere, which is pi r squared, that's a whole hemisphere. Now there's two ways you could look at it. You could look at the half of the hemisphere would be 2 pi r squared, or we could look at the whole hemisphere here would therefore be 64 pi. You could look at either way. I'm going to go with the 2 pi r squared of the hemisphere. This is the surface area of the hemisphere is equal to that, which is equal to 32 pi. I need my r. And what we can see is I can divide by 2, I get r squared is equal to 16, therefore r 4. So that was the tricky part of the questions, to find r. Now we've got the surface area of our cylinder, and we can see the surface area of the shape, write it out again here, is going to be 2 times pi times r times by the height 10 plus 1 other pi r squared, pi times 4 squared, plus the 32 pi. Now what you noticed here is I didn't really read the question properly. The student might have realised that I thought I was just going to get this and then just add on the 32 pi. Then I realised suddenly I didn't have r. I had to go back and find r. And that's how you can build up questions and spot what you've got to do. Right? There's no bad thing that you don't spot things. It's just realising on the fly that you need to correct your mistakes. So therefore we've got 2 times 4, that's 80 pi plus 16 pi plus 30 pi. I'm going to add the 16 to the 32, 42, 48 onto the 80 gives me 100. Pi as my final answer. Right, we've got a bit of time today, so we will have a bash at the exam question in the lesson. I've been leaving this previously for you to follow up on your own, but we can have a go at doing this today. This is trickier than all the others, and I've noticed some people joined the stream late, and they might find that a little bit tricky if they haven't seen all the other questions. Okay, so it's a little bit trickier than all the others. I will give you 4 minutes to have a go at this, and then I'll run you through it. Okay, that's 4 minutes. Don't worry if you didn't get to the end of the question. What you can do is obviously download the notebook and have another go at this lesson later on, and try and do the question again later on, see if you can do it in, wipe out all the answer and see if you can do it in 4 minutes. Then give yourself a couple of days to possibly forget what you've learnt and what the answer is. We have another go, and then again have another go in about a week's time. So I'm just going to give yourself some space to work in. So we've got a diagram that shows a solid metal cylinder, radius 3x and height equal to h. And it's melted and it's used to make 270 spheres, and each sphere has a radius of a half x. To write an expression in simplest form of h in terms of x. So we're dealing with volumes here. So let's start off with the volume of the cylinder. The volume of the cylinder, as we should know by now, is equal to pi r squared h. So in this case, it's going to be pi. Remember, we square the whole of 3x, and we times the volume of our cylinder is going to be equal to 9x squared h. And the metal cylinder is melted, and all this metal is used to make 270 spheres. So let's find the volume of one sphere. So the volume of one sphere is going to be 4/3 pi r cubed, and r is equal to x over 2 or half x. And again, common mistake is just to cube the x and not cube the half. We're going to avoid that mistake. X cubed is x cubed, 2 cubed is 8, and we can simplify this because 4 over 8 is just a half, and we've got 4/3 times. Actually, what I'm going to do, we'll do that. Sorry, I'm going to write it so I cancel out that with that 8 to 2. So we've got 3 times 2 is 6. 1/6 of x cubed. That's the volume of one sphere. So the volume of 270 spheres is going to be equal to 270 over 6 times cubed. And we know that that is equal to volume of a cylinder. So let's make this equal to each other. So we get 270 over 6 times pi times x equal to 9x squared times the height. Straight away we can cancel out the pi's. We can also cancel out all the x squared there with, and just leave x here, because x times x squared equals x cubed. So when you cancel out the x squared, you just be left with the x. So we've got 9 and h. Let's just see if we can just cancel this down a little bit. Well, we know that 9 goes into 27 3 times, so that's going to cancel down to leave me 30 over 6 x, which is just equal to, cancel out that 9 there, that there, 30 over 6x equal h. And then we can just divide the 30 spacer. I can just squeeze in 30 divided by 6 is equal to 5x h, and that's to that question. So that'll do for today on this. What you will notice, actually, if I just minimize my book so you can see more of the notebook, let's look at the note here. See, I also have got volume and area scale factor questions in here, which I didn't do today's lesson because we're really concentrating on this type of question. We're doing a lot of cancelling out of volumes and stuff and using the formulas a lot. So you'll see I did easier exam question 1, 2, and some of the questions from here, with which these answers to these questions. This video here, if I go to this one, is what I did previously. And I think there's a lot more on the volume scale factors questions. If you want to go and look at those, you can go through this video and it will go through that as well. Okay, so you can go through that. I'll also put today's video in this page here, which goes through these questions here, okay, and looks at the exam question that we've just done there. Okay, if you have any more questions and answers you want to do over microphone and stuff and look at other questions, I'm going to open up a Zoom lesson in just a couple of minutes. We'll do it at 10:40. I'll give you a 2 minutes break. That.